phase and phase difference. This is very important aspect to understand whenever we apply a single phase AC to a resistive circuit, inductive circuit, capacitive circuit. Definitely it becomes very necessary for us to understand the nature of the current created in the circuit. When you apply a sinusoidally varying voltage to a resistor, what is the nature of the current flowing inside the resistor in the circuit? Is it sinusoidal? Is it other than that? Is it really following the same as that of supply voltage? That kind of relationships between the wave to wave we need to understand. Then to have that, let us say a waveform which is shown to you in the graph, which is one with a larger peak value. Can you see this? Yes, sine wave 0 to 2 pi. Another wave is represented just inscribed inside this. Can you see this? Lower peak making a half and second half. This is also sinusoidal. Now what is my intention over here is, do these two waves start at the same point? Yes. Do these two waves attain peak of themselves at the same time at pi by 2? The wave number 2 appears a peak and wave number 1 also attains a peak. So peak values of the respective wave are appearing at the same instant of time or angle, and they are going to 0 at the pi. Both are going. They are going to negative cycle. Yes. They are having a peak value. Yes, they are having a peak value similar time, and they are having a reversal to 0 at the same time. It means I can say, if I speak wave number 2, which is a smaller in peak quantity, is following the wave number 1 like a hand in hand. The variation on the wave number 2 are occurring at the same instant as that of wave number 1. Means 0 crossing, both are 0 crossing. Peak attainment, both are attaining the peak at the respective time, and crossing to 0 again at the same time, and attaining the negative peak at the same time, returning back to 0 same time. Then I would say the relationship between them is hand in hand. We call them as in phase relationships. So I established a new relation, in phase. Before that, we need to see where it is applicable, why we are studying this, like that. So I said, whenever we apply a alternating voltage to a resistor, inductor, capacitor, definitely current will possess its relationship with the applied voltage, sometimes with respect to an element in phase, sometimes phase lagging, sometimes phase leading with respect to nature of the circuit. The circuit is resistive, current follow the voltage, nothing but in phase relationship. If the circuit is inductive, current is tailoring behind the voltage applied, we say lagging. If the circuit nature is capacitive, current leads ahead of the applied voltage. In that relation, understanding of phase and phase difference become very necessary. Let us take what we mean by that then. What is a phase? Phase is an angular displacement of the vector representing the quantity. Now question comes, why we are speaking about the phase then? Let us take one more step ahead. Let's take this and come back to this. Yes. Can you see this wave? This is a sinusoidally varying quantity. Sinusoidally varying quantity can be represented by a rotating vector. This bluish line, which you can see, is a vector having a magnitude and angle, and it is representing a certain arbitrary position, which is known as a vector representing the alternating quantity at this point of observation, at the point of 0 to 50 degree. When I observe, what is the instantaneous value I am trying to observe here? It means to say, if at all, if I represent a vector for the sinusoidally varying quantity, let's say a vector is bluish like this, which will be horizontal in plane. Originate is lying, resting on the horizontal axis. And as we proceed from this point forward, that vector start rotating in the anti-clockwise fashion. Now it's a very simple thing. This is the vector. When I say vector, vector is going to have a magnitude as well as direction, like an angle. As well, when I move along the profile of this wave like this, when I trace this vector, as I move forward, vector start running like this way, rotating in the anti-clockwise fashion. This is called rotating vector. We call it as phasor. Vector which is having a magnitude and direction is revolving. We call it as a phasor, but we can even invariably people refer it as a vector, which we call a rotating vector. Now, this concept, whenever I say a reference vector for the particular wave is say at point 0 landing horizontal like this way, horizontal axis. Then when I make a shiftment, a phase of a wave at particular angle, when I move along this line slowly and stop, and it made a shipment of how much angle? 50 degree. I have made along this line a shipment of an angle of 50. 50 degree is the phase of the quantity what I am considering at this point. Phase is the angular displacement of the vector representing the quantity got shifted from the reference point. Now you can say when VP, this is lying horizontal, it means it is a reference point. Let's say it's horizontal, along the horizontal axis. It means I am at the 0 mark. When I move along this path, this vector will shift upward, 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 upward. As I move forward, it keeps shifting in an anti-clockwise fashion. Certainly, when I stop at this point, what is the angle I have got shifted? I can project down an arrow and I can see what is the angle here. Or this vector which was lying horizontal when I was at 0 point, took a shipment. When I took up to this point, this vector stood this much angular spread. It took an angle of how much? 50 degree. Then I would call phase of an alternating quantity is the angular shift that the reference vector representing the sinusoidal quantity shifted from the reference. So 50 degree is referred as a phase. Phase is an angular shift that the reference vector representing the quantity shifted from the reference. It may be positive side or it may be negative side. We say progressive waves. When I say progressive, moving right side as it is angularly, then this vector will rotate anti-clockwise when the waves are progressive. If the waves are retrogressive, if instead of going upper like this, if I go reverse in a reverse manner towards the left of my page, it become retrogressive. At that time, the vector representing such a quantity will revolve clockwise direction. Hope you are able to follow me. The vector representing the alternating quantity always having its reference axis horizontal, which is nothing but 0 mark of this. Let us say I have to come to this point once again. There are a lot of things to discuss on this point. For me, I want to convey what is a phase. Phase is at any point, at this point, at this point, at this point. I want to define what is the phase of this sinusoidal quantity. Phase I am trying to define. Phase of an alternating quantity is the angular displacement that the vector representing the quantity got shifted from the reference point. So certainly one example which is on the screen here, if I stop at this point, I am moving along the profile, I stop this. What is the phase of this quantity? I can drop a perpendicular line to this axis and get it as a 50 degree. Or when I was moving along this profile, this vector which was lying horizontal should rotate in an anti-clockwise fashion. Then that got shifted and stopped here, because this point I just touch a circle formed by this vector. This is just imagine a circle here. This is rotating. Just remember, I'll speak what is that later. This is revolving here. That is an imaginary circle is formed here. Imagine a circle, to the circumference of that, this line is touching. Then join that. That is called as angle of 50 degree. Or this vector stood 50 degree away from the reference point. This angle we call as phase. Phase of an alternating quantity is the angular displacement that the quantity got shifted. Then what is the phase difference then? When I have two quantities, one quantity I can replace by one vector. If I have another quantity, I can replace by another vector. When both the vectors are revolving, difference between those two I can speak. That is known as phase and phase difference. Phase difference is the difference in the reference vectors of wave number 1 and wave number 2, like that. So let us, this is about the heading. Let us see a quantity by chance. So if I represent the first wave, like certain peak value is put here, Vp sine theta plus or minus phi. Originally, let us consider sine theta. Let us not consider plus or minus phi, which is called phase shift. Let us assume Vp sine theta. Sinusoidally progressing wave, which is sinusoidally progressing wave, like this. Then I can have another wave which is sinusoidally progressing. So phase of an alternating quantity is the angular shift that the quantity's vector got shifted from the reference. That's how any quantity which is sinusoidal, Vm sine omega t, Vp sine theta, like that can be redrawn. Suppose that angular progressing velocity, now I am using the word angular progressing velocity of the wave, like Vp sine, instead of this theta, if I speak omega t or theta is known as angular progressing velocity of the wave in radians per second. See very carefully, angular progressing velocity of the wave is omega t or theta over here, which is in radians per second. Apart from that, you can see when omega t is 0, sine 0 refers to this point. When sine refers to pi, it refers to this point. When sine refers to pi, it becomes a complete part. In between 0 to 90 degree, it is a projection going like this. When it is 90, it comes to this point. And 100, 110, it starts rising, it starts falling back to pi. Later, pi to 3 pi, it will run into negative cycle. Likewise, any alternating quantity, when omega t is represented, omega t equal to 0, 10, 20, 30, like that, in either degree representation or in omega t directly as a radians representation, I can project it as a waveform. Suppose if I have a quantity sine theta or sine omega t alone, it would look like this. There could be another representation, which is apart from the omega t or theta, you have plus or minus some arbitrary angle phi is mentioned. Then what is this? The first term is called angular progressing velocity of that wave, which is omega t. Omega equal to 2 pi f t. We can split it up and understand. Let us say apart from omega t, I may have plus or minus arbitrary angle phi. Then what is the description of this phi? Phi is called phase shift. It means where do this wave begins. Suppose this phi is 0. What is the meaning of this? Phi is 0, omega t plus phi. Omega t is 0, it is a beginning here. So suppose this is 10 degree. Omega t equal to 0, it is 10 degree. Then what is sine of 0 plus 10? It is a 10. Beginning of this is plus 10, late by, like that. So therefore, we should be very, very careful about these things. So we will see this. So when is plus, when is minus, we speak of lagging as a minus, leading as a plus. This same graph I will consider it as plus means I go backward, minus means I come towards the real axis right side. We will see it very soon. Invariably, the angle which is mentioned over here, apart from the angular progressing velocity with the sign plus or minus an angle, we call it as phase shift or phase difference. Let us say when two waves are represented on a scale, they are having similar fashion of representation. I can tell them as they are possessing in phase relationship. Vector representing quantity number 1, quantity number 2, different in magnitude, but they are following the same pattern of following nature. We call it as in phase relationship. Let us move further. Let's see here two waves. Wave number one is bluish in color, which you can say reference. Then the wave number two is having red in color. It is starting late by an angle phi. You observe the zero mark here. Zero mark is exactly zero of a graph sheet plot. Correct now? Then the wave number two is crossing zero later by an angle 45, or it is in the negative plane here. When this is zero, it was a negative. Then I start of this I consider as a beginning, because I want to make one cycle of observation, a positive half and a negative half. When I consider this become a complete cycle. For this one complete cycle of wave number one and wave number two, this is called reference. Any one is maybe reference and my another wave. I want to understand how is that relationship between wave number one and wave number two is defined. Now we can see whenever omega t equal to 0, it is the beginning of first wave, but it is later by an angle 45. It means say 0 mark of this wave is at 0 of your start. It attains the peak at exactly 90 degree or pi by 2, and it goes to 0 at 180. It goes to peak negative at 270 and comes to 0 at 360. This is the natural cycle sine omega t. Correct now? Then you observe this one. This is not at the 0 mark. It is tailoring behind this. Imagine this wave is progressing. This is progressing hand in hand, but late by an angle phi. It means it is following the first wave by an angular difference of phi. Because this is a scale in degree, I will say 5 degree behind this. Then 0 mark of this is at 0 degree. 0 mark of this is later by an angle 45. This blue reference wave attain its peak at 90 degree only. Then when do the peak of this red wave appears? By this 90, later to that 145 degree. That is what 90 plus 45. It is 135 degree. I will find. What is the observation here? The peak of the wave number 2 appear 45 degree later to that of wave number 1. Hope you understood. Start of the wave number 2 is 45 degree later to the wave number 1. Peak of the wave number 2 is later to the wave number 1 by lag of 45 degree. Similarly, when the first wave crossed the 0 at 180 degree, when do it will cross? Plus 45. Then what is this relationship I am trying to establish here? Wave number 2 is said to possess phase lag relationship with wave number 1 because respective points on wave number 2 appear later to that of wave number 1 by 45 degree over here. It means the pattern is sinusoidal, but any observation like a zero crossing, attainment of peak, another zero crossing towards negative cycle, attainment of negative peak, respective points I am speaking, they also appear on a red wave, which is a second wave. But respectively, when I collectively say wave number 1 and wave number 2 comparison, wave number 2 is said to possess respective points like a wave number 1 later by an angle 45 degree. Then I would say wave number 2 is possessing phase lag relationship. You can see here, I have just marked here. This is an angle lagging. Hence, this angle must be put as minus in the basic equation. Suppose this wave blue is said to have, suppose the voltage Vm sine omega t by chance. Then what would be the wave here? Something like Vm1 sine omega t minus phi. Minus phi indicate that wave number 2 is starting later by an angle phi mentioned. Hence, negative is the phase shift mentioned in the waveforms. Then, can you see this wave now? The similar waveform, reference wave is blue again. It begins at 0, goes to peak at 90, goes to 0 at 180. It is cycling correctly up to one cycle of observation. Now, with respect to this, notice the red wave, which is beginning before this by an angle 45 degree. You can see this. It is beginning earlier to this by 45 degree and makes it one complete cycle. Can you see here? Correct? I trace it. Yes. Now what is that? You get a relationship here. Wave number 1 is advanced to wave number reference. Wave blue is your reference wave. Wave number 2, respective point on wave number 1 appear in advance by an angle phi compared to that of wave number reference. You can see 0 mark. 0 mark appear exactly on the scale 0 here. What about the wave number 2? It is experiencing this 0 advance. It is 0 before this only. 45 degree earlier only it experiences 0 mark. Then this blue line experience at 90 degree a peak value. Correct? This has already experienced the peak. Before that only at 45 degree only it took its peak attainment. It is taking its peak at 90 degree. Then what is our observation? Respective point on wave number 2 appear 45 degree earlier to that of wave number 1. Then wave number 2 is said to possess phase lead relationship. Phase lead means that wave is leading with respect to any other reference. You can see here the reference wave is taking its negative turn beginning at 180 degree. It start to enter negative at 180. How is this red wave? At 135 only it started negative phase. It means this is advanced by an angle 45 degree. That is the reason phase lead means wave number 2 is possessing phase lead relationship with respect to wave number 1. That is the reason respective points on wave number 2 appear earlier by an angle phi, like 45 degree here. That's what I have mentioned here. So note that leading sine wave above the axis is leading because it started earlier to this. This we will not write this as a negative like a conventional graph sheet scale, positive axis, negative. This is advance means for me it is a plus. So likewise you can see, and there is a positive shift here. This negative value will not consider. We will consider beginning earlier to the negative point, earlier to the 0 mark. So earlier to 0 mark, no doubt on a geometry sheet is a negative cycle, correct now? But that angle we will not think negative. We think it as the beginning of the wave earlier to the 0 mark as leading angle value. That's called shift must be positive. So I go back to the first screen and see. Here I said Vp sine omega t. This phi is not there. That is a conventional in phase relationship. In phase means swinging hand in hand. Suppose there exists a difference between the waves. One wave start earlier, one wave start later. So that is the case. We think of phase difference. Phase difference can be lagging or leading. Suppose in this wave plus or minus, if I speak theta minus phi, minus means lagging. The particular wave with the minus certain angle is starting later by an angle. Plus means starting earlier to the reference wave. So we refer plus means earlier beginning. Minus means tailoring behind, begin later. So I go back here. This is beginning later. 0 is here. 0 mark of this is here. Later by an angle phi. And this is called lagging. So it would be Vp sine omega t minus phi for this wave. Then if this is the case, wave number 2 is beginning advanced by an angle phi. We will say the wave of this is possessing a lead relationship Vm or Vp sine omega t plus phi. We will not consider real minus values here. We will consider what is that angle it took its start earlier to 0. That is called leading with respect to reference wave. Begun earlier to the reference wave, that we call as lead relationship. That is mentioned as plus in the omega t. Omega t plus an angle leading. Omega t minus the angle lagging. Only omega t in phase relationships. Now I disclose. In electric circuit is said to be resistive. We will experience in phase relationship of voltage and current. Current is in phase with the voltage whenever circuit is resistive. In case of lagging, current in a inductive circuit, current lags behind the voltage. That's called lagging concept is understood in inductive circuit. In case of capacitive circuit, current leads ahead of the voltage, then the circuit must be capacitive in approach. Therefore, these three basic wave and wave differences, wave phase differences must be remembered by us. Whenever I study single phase application to a resistor, so current and voltage will be in phase. Whenever I study a single phase application to a inductor, then lagging current is there. Current must be lagging. In case of capacitor, current must be leading. So these three relationships should keep in our mind, should be kept in our mind, and should be utilizing it to our case studies. This is about wave and wave differences. Now next question is it really necessary for us to draw the waveforms all the time whenever we understand the relationship between them, or is there any other technique to represent it? Yes, there is another technique called representation of alternating quantity by a rotating vector. That's what I wanted to convey you. Let's see this vector. It means I have a sinusoidally varying quantity. Yes, then a quantity, when I trace it 0 and go to peak and come down and back to negative, like this way, if I trace this cycle, this is actually a progressive sine wave. Can I represent progressive sine wave by a vector? What is a vector? Vector is a quantity which is having a magnitude and direction. But here, alternating wave is not a vector. It should be represented by a vector because at any discrete point, it possesses a magnitude and a direction. And it possesses a magnitude, direction, magnitude, direction, magnitude, direction. But it is changing its position also. Not only having a magnitude and direction, it is changing in its position. Hence, it is possible to represent sinusoidally varying quantity by a rotating vector. We call it as a phasor. Then how it is represented? Yes, look at the representation. Let us consider a sinusoidally progressing wave as omega Vm sin omega t, where omega t is called as angular progressing velocity of the wave which is progressing, having its peak value Vm and minus Vm respectively. Now, how it is possible to represent? To represent alternating quantity by a rotating vector, we require three parameters. It is possible to represent the alternating quantity by a rotating vector. First concept is possible to represent by a rotating vector. Vector should lie along the horizontal axis. Can you see this? Which I am marking here horizontally? It should be the reference point. The length of this vector is the maximum value available in the wave. What is the maximum value available in the wave? Vm. Vm is the magnitude of the vector lying horizontal like this, which the cursor of the mouse I am hovering like this. You can see. It is possible to represent alternating quantity by a rotating vector, and vector should lie along the horizontal axis with its magnitude equal to peak value available in the wave. First point. It should progress. The wave is progressing with the angular velocity of what? Omega t. Now, this vector, which is lying horizontal, should revolve in the anti-clockwise fashion, rotate in the anti-clockwise fashion at the same rate as that of omega t. Wave is progressing forward with the omega t. Then this vector, which is lying horizontal in the original position, referring to this point number 0, it should keep rotating in the anti-clockwise fashion with the same angular progressing velocity to represent the progressive waves. Suppose if the wave is retrogressive, going reverse, this vector which is lying here should rotate clockwise. Hope you are able to see. Progressive waves are represented as anti-clockwise rotating vector. The retrogressive waves are represented by a clockwise rotating vector. So all our standards are concerned with the progressive waves. Therefore, whenever we say waves connected to electrical systems, definitely they are progressive waves for the simplicity of understanding. When that is the basic understanding, vector must rotate in the anti-clockwise fashion. That is the default nature of the rotation of the vector, which is a phasor. So therefore, this wave is represented as a magnitude peak value appearing in the wave lying horizontally at the origin point, and as the wave progresses forward, this vector start rotating at the anti-clockwise fashion. You can see when I move 30° up, you can see 30° forward, move here and stop. Then this means the vector representing this quantity Vm magnitude, which was lying here, has to take a shift of 30°. You can see here omega t is 30°. Mark 30°, draw the line. This refers to the phase. What is the phase here? Omega t is the shiftment. 30° is the phase at this point. So vector got shifted by an angle 30°. Then when I move forward with the next 30°, 60, then this vector should go upward by an angle of 60 and draw the line. Likewise, it keep on tracing a circle with the radius equal to what? Peak value, or diameter equal to peak value. At what rate they are rotating? At the rate omega t. So this is the concept of a phasor, rotating vector. It is having a magnitude and a direction, and it is rotating. Hence we call it as a phasor. Therefore, it is possible to represent an alternating quantity by a rotating vector whose maximum magnitude is equal to maximum value available in the wave, which is lying horizontal to create initial zero mark. And as the wave progresses forward, any instantaneous value at this point, at this point, at this point, how to obtain it? Take the projection of this vector. This got shifted by 30°. Take a 30° shift, draw it, and put a torch from the rear side here, from this side. The projection of this on the vertical axis, I have to measure this length. This length is nothing but from this end. If I measure this shadow of this fall on the vertical plane. So any instantaneous value of this quantity. What is a waveform? Waveform is a graphical representation of variation of a quantity with the time. Other way, it is the collective joining up of instantaneous values together to create a profile. Then instantaneous value, when the waveform is not there for your view, assume that waveform is not there. How can a vector understand? How can you understand it from a vector? Yes, when a vector is shifted by an angle omega t, then this is nothing but a position on the graph like this. This is a shift of 30° means what? Vector took up by an angle 30. What is the magnitude available here? On the graph, you touch it here, read on the vertical axis. You would have read this magnitude on the graph. But this graph is not there with you. How do you read it from the rotating vector? For that, we have to imagine this particular vector. When a torch is put from this side, the projection of this along the vertical axis. This axis is called vertical axis, another is called horizontal, as it is a reference axis and 90° axis. So on the vertical axis, the projection of this vector, which is dotted line, you can see dot 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 dot, it touch here. This is the magnitude. Read this magnitude, nothing but same height here. This is the height, this is the scale, which is not there. I am able to read this. This I am able to read means the instantaneous value of the quantity at any instant of time is the projection of the rotating vector on the vertical axis. These are the three important points. If I understand, I can replace sine wave by rotating vector. I repeat, it is possible to represent alternating quantity by a rotating vector. First concept, whose magnitude, maximum magnitude is equal to maximum value appearing in the wave, which is lying along the horizontal axis, which should rotate in the anti-clockwise fashion to represent progressive wave, and instantaneous value of the alternating quantity at any instant of time is the projection of that vector on the vertical axis. So if I move 30° plus 30, this keep shifting up, shifting up, shifting up like this way. Any line which is bluish in color, which is a red, is a sample 30° shift. Suppose if I take 120-degree shift, I came to this point. At this point, what is the phase of this quantity? Phase of this quantity is, what is the angle you shifted? 120. That is nothing but this vector is representing a quantity. It was originally here 120 degree. If I read here, this angle between this reference and this point is 120. Phase of the alternating quantity is 120. Phase can be how much by value? It can be 0. It can be highest of 360. Value of phase can be 0 to 360 highest. After the 360, it retraces the circle. So therefore, phase is an angular shiftment that the vector representing alternating quantity got from the reference point. It can be positive, it can be negative. Normally, progressive waves will have positives, retrogressive waves will have negative. So therefore, this is the relation between how a sinusoidally varying quantity is represented as a revolving vector. That revolving or a rotating vector, we call it as a phasor. It is revolving at the same rate of progressing velocity of the wave. So this we need to understand. So it is going to rotate in an anti-clockwise fashion at any instant of time. Instantaneous value is projection of this vector along the vertical axis. Suppose at this time 150-degree phase shift, it has got shifted to phase shift 150 degree. Then how do this vector goes? From this point 150 degree you measure here, draw a line here. So it is a stop point. And what is the instantaneous value at this time? This is the height. How do you get it? Put a torch from this side. Torch here, shadow of this line comes on this vertical line. So this vertical line, the projection of this on the vertical line shows the instantaneous value. Suppose you are in the negative phase, somewhere 240 at this point. How do you do? From this point 240 you measure and stop. Draw the vector here. This became vector representing the quantity shifted from the reference by an angle 240. Then what is the instantaneous value over here? This is the height, correct now? How do you get it without this waveform? From this side, put a torch. The projection of this along the vertical axis. You have to put a torch, shadow of this fall here. That magnitude we have to read from the representation. Likewise, you may be in first quadrant, second quadrant, third or fourth. Like we can divide first 90 degree of this representation. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Like this, you will be falling here. First one, second quadrant, third quadrant, and fourth. So when I divide 360 degree by 4, 90 degree each. So first 90, second, third, and fourth, I can go around this. This is just a knowledge one should have how it is possible to represent alternating quantity by a rotating vector. Now I took this example very well advanced because I wanted to tell you people what is a phase. Phase of an alternating quantity is the angular shiftment that the vector representing the quantity got shifted. Now I can say reference point was horizontal. How much is the angle it got shifted? 50 degree. Then phase of this quantity at this point of observation is 50. An example is taken. A plot of example in the previous slide, which was peak of 25 volt is shown. The instantaneous voltage at 50 degree, if I wanted to know, then 50 degree when I touch it, this value I want to know. So this value I can read by scale if I have a graph. If I do not have a graph, then what I should do? I should have this wave represented by a vector. At this original point, it is lying horizontal. What is the angle you want to have a shift? 50 degree. Make a 50 degree mark, shift it over here. Length of this VP must be equal to 25, peak value. Then angle you got shifted is 50. Then put a torch on this. The projection of this on vertical scale give you the value of 19.2. It is called VP sin theta. You know this. This is a triangle. This vertical side, this vertical, if I touch this, dot, 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 vertical side over here of the same length of this vertical side. So this is theta. This is the hypotenuse. You know the angle, you know the hypotenuse. Two quantities of a triangle are known to you. You cannot get the opposite side here. This opposite side itself is the side over here. Opposite divided by hypotenuse works with sin theta. VP sin 50, nothing but vertical side. That is the VP sin theta. So like this, the instantaneous value of a alternating quantity at any instant of time by the vector is shadow of that, projection of that along the vertical axis, I can calculate. Sine function I should use. Peak value and sine of the angle shifted I have to use. 25 peak, suppose 240, 25 sine 240 give you the instantaneous value of this vector. Likewise, this is used in the technical analysis. So suppose if I have a phasor in this way, the phasor can be like this. Real axis, see how I am marked here. Real axis is my reference axis. Imaginary axis is shifted by an angle 90 degree. It can be represented as 20 sine omega t minus 30. What is the meaning of this? This wave, voltage wave, is having a peak of what? 20 and sinusoidally progressing with the omega t angular velocity and having a lagging phenomena by what degree? 30 degree. Suppose I have a vector of 20 lying over here, which is omega t, no angle over here. But there is an angle of how much? 30 degree. Then I should have from the reference draw 30 degree a line, vertical, situate a vector of what magnitude? 20. 20 is the magnitude. It is not along the reference. It is lying below the reference because it is omega t minus 0. Omega t refers your reference axis. Omega t is your reference. Below the reference by an angle 30 it exists. By what magnitude? 20. 20 is the magnitude of the vector and it is lying below the reference by an angle 30 degree. This is how it is drawn on the representation. In polar representation, you are already aware that rectangular and polar are the two types of complex representations. Therefore, in case of polar representation, magnitude and angle is represented by a symbolic representation 20 angle bracket minus 30. It shows that 20 is the absolute value, magnitude minus 30 shows angle with which this vector is behind the reference. If the reference is horizontal axis, behind this by 30 degree, 20 magnitude a vector is drawn. That is called 20 sine omega t minus 30 representation. By chance it is a plus here, you can see here a current wave, something like that, 15 sine omega t plus 45. What it would mean? It is reference axis plus 45 degree and cut the length equal to 15. It is magnitude of 15 and position of that is 45 degree above the reference. Therefore, this represents another kind of instant of a phasor, which is 15 sine omega t plus 45. In case of representation by polar, how it is drawn? I equal to 15 angle 40. We can see the difference here. 20 minus 30 says lagging below the reference axis. It is 15 plus 45. It is not 0. 15 angle 0. 0 means horizontal here. It is plus 45. It means a 15 magnitude 45 degree shift upward by positive direction. Therefore, it is given as 15 angle 45. Likewise, our understanding in this chapter should go slowly so that we are able to understand application of single phase AC to resistor, inductor, capacitor, hybrid combination RL, RC and RLC in series and parallel together in the next module like that. So we have to bridge our fundamentals for the next coming chapters like this way.